Solve each rational equation. Our first example, we have x minus 3 divided by x less than 0. We want to know all values of x that make this statement true. The numerator will contain the zeros of the rational term, rational function. So x minus 3 is equal to 0 when x equals 3. And the denominator is undefined when it's 0. And that will occur when x equals 0. So we're going to mark off the key numbers where the rational expression is 0 at 3 and undefined at 0. Then we're going to test numbers around and in between the key numbers. -1 subbed into the original problem, -1 minus 3 divided by -1, that is not less than 0, so this interval is full of bad numbers. We test in between the key numbers, and we picked a positive 1. Substitute into the original problem, 1 minus 3 divided by 1. That is less than 0, so this interval is full of good numbers, or solution values. And then finally, we test to the right of our last key number. We used a 4. 4 minus 3 divided by 4, that's positive, so not less than 0. The only interval that satisfies our problem are the numbers between our key numbers of 0 and 3. In the next example, we have a rational inequality that's not put greater than or equal to 0. So our first move is we're going to subtract 3 to move it over. X plus 10 over x plus 4 minus 3. We're going to create a common denominator of x plus 4. So I'm going to take 3 and multiply it by x plus 4 and then divide it by x plus 4. Now we have a common denominator of x plus 4. X plus 10 minus 3x minus 12. That'll be our numerator once we clear the parentheses. Combining like terms, we have negative 2x minus 2, still over x plus 4. Now that we have our inequality with 0 involved, we can find our 0, which is when the numerator is 0. That occurs when x equals -1. And then our other key number is when the denominator is 0, and that occurs when x is -4. So draw a number line, mark your two key numbers. In this case, it's -4 and -1. And then we'll pick test numbers between and around the key numbers. -5 was one of our test numbers. -2 times -5 minus 2 over -5 plus 4. And you guys told me in class, 10 minus 2 was 8 over -1. That's not greater than or equal to 0. So this interval does not have our solution numbers. Testing between the key numbers, we picked a -2, substituted in. -2 times -2 minus 2, that's positive 2 on top. -2 plus 4, that's a positive 2 on bottom. 2 over 2 is 1, which is greater than or equal to 0. So we know this middle interval of numbers will satisfy our problem. And then this final test number of 0, -2 times 0 minus 2, that's -2 over 0 plus 4 is 4, so that's -1/2, which is not greater than or equal to 0. And so the only interval of numbers that satisfies our problem is from -4 to -1. Because the inequality is underlined, we include the 0. We do not include the undefined key number. Three over x minus 7 greater than 1 over x plus 1. Excuse me. In order to force a 0, I'm going to subtract the fraction on the right so I can move it to the left. This is where that has been moved over. Now we have greater than or equal to 0. We have two factors that are unlike. So for each of these two fractions, I'm going to create a common denominator of x minus 7 and x plus 1. In the first fraction, we already have x minus 7. We do not have x plus 1, so multiply it into the top and bottom of that fraction. This fraction has an x plus 1 in the denominator. It does not have the x minus 7, so we'll take our fraction, multiply in x minus 7 on top and bottom. 0 times whatever you multiply it by is going to remain 0. And then now, 3x plus 3 minus x plus 7. Combining like terms, that's 2x plus 10. And then since we forced a common denominator of x minus 7 times x plus 1, we will have a reduced fraction of 2x plus 10 over x minus 7 times x plus 1. We're going to find out where that's greater than 0. Our numerator is 0 when x equals negative 5. Our denominator is 0. Let me collapse this a little bit, y'all. There we go. Up here in the light blue, the denominator is 0 at 7 and negative 1. So these are our two key numbers where the rational expression is undefined. Negative 5 is the 0, or where the numerator is 0 of the rational expression. Excuse me. Okay, so here we sketched a number line. Negative 5 was the 0, negative 1, positive 7. That's where we had undefined values. So there were three key numbers. Testing this interval, we picked negative 6. Plug negative 6 in for x. And you can check the original problem. Subbing in, we got a contradiction, so we did not keep that interval of numbers. The next interval we tested with a negative 3. 3 over negative 3 minus 7. Turns out that that is greater than 1 over negative 3 plus 1. So this interval of numbers is good. Between negative 5 and negative 1, we kept that interval. The next interval, the third interval of numbers, we tested with 0. 3 over 0 minus 7. Turned out it was not greater than 1 over 0 plus 1. And if you do a quick check, negative 3/7 is not greater than 1. So this interval was out. It didn't have good numbers. And then finally, we tested a fourth interval. We used an 8. 3 over 8 minus 7 is greater than 1 over 8 plus 1. 3 is greater than 1/9. So we kept that fourth interval of numbers, which is 7 to infinity. And since the solutions to this problem are numbers in the interval from negative 5 to negative 1, also numbers greater than 7, we unite those two intervals with a union symbol to show that these two intervals of numbers unite for the solution set to that inequality.